Oh, this is another look at exercise 12B. Last time we saw how to do them on the calculator. One of the things I want to do today is make sure you can do them just using pen and paper. We also want to do some other bits and bobs with parametrics as well. So let's move on quite quickly. A little starter for us. Based on what we did last time, can you write these parametric equations in Cartesian form? You might want to pause the video, or if you can't remember how to do it, you might want to just watch me do it. But I'd probably recommend you pause the video and see if you can do them yourself. So pause now. Okay, so if you have managed to do that, brilliant. If you haven't, this is what we were playing around with last time, wasn't it? So first one I'll do over here. I suppose the easiest way of doing this is to write t equals. So just rearranging this, I reckon I get y plus 4 is equal to the t squared, just by whacking that over there. And therefore t, by definition, is the square root of y plus 4. Now I can just sub that into here, because I've got x equals t to the 5. So it's like y plus 4 square rooted to the power of 5. And probably the best way of writing that is it's y plus 4 to the 5 over 2. And you could even move the square back again and get x squared equals y plus 4 to the 5. It'd be interesting to see what the answer says it is. Because I could multiply that out, I could do a variety of things. So one of those two, I'm sure, is what I've got. This one now, it's got sine and cos again, and I remember this formula that said cos squared theta plus sine squared theta is 1. So if you remember that, you think, well, I've got cos squared already, but just need to square that one. So if I square that one, x squared equals 16 sine squared theta. And I know this. Now move the, so I've got x squared over 16 is sine squared. And on this one, presumably y over 3 is cos squared. And now I can just go back to my identity, which I know is true. Cos squared is y over 3 plus x squared over 16 is equal to 1. This is actually some weird shape, I'm sure. But this is, I think, the right answer. Let's see if I've got the answers. Now that's interesting. On this one, I've rewritten this in a different way completely. But again, still right. This is right. I'd be able to get this from this. And it's one of the things about these. You're not really sure when you've got the answer they want. That's why sometimes it's best just to get the answer and just, that'll do. This one is exactly what they've done, although I've written it in a slightly different order. But other than that, they're good. A reminder, the next few lessons we'll need to remember this. So just remember, if you've got tan x and you differentiate tan x, you get sec squared. So I'll say again, if you differentiate tan, you get sec squared. That's another way of writing it. So let's do an example then. It's an example to basically draw the parametric equations that you get from this. When you do this, you usually get a table of values. So it says here x equals t squared minus 1. So based on that, I'm going to start with the easy numbers. So 3 squared is 9, take away 1 is 8. That's 4, take away 1 is 3. This is 1, take away 1 is 0. This would be minus 1. And then presumably these will just be the same numbers. Because when I square minus 3, I get 9 still. Y equals 2t, oh that's easy enough, I just double all the numbers, double all the t's. And you end up then with a set of coordinates effectively, like that. And we have to draw these. So, right, I'm just trying to make sure I've got enough space. So I reckon there's a good place for any for my x-axis. And I'm going to put my y-axis here. Just looking at my values. Hopefully you would do this with a ruler, who knows. So I'm going to say this is 2, 4, 6, 8 going across. Presume that's minus 2. And then I've got to get up to 6, so 2, 4, 6, and I've got to get down to minus 6. Minus 2, minus 4, minus 6. And I'm just going to plot these coordinates. 8, minus 6. So 8, minus 6 all the way down there. And I've also got an 8, 6 on the other end. I'm going to do them at the same time. 3, minus 4. 3, minus 4. Is it 3, 4 as well? It is. 3, 4 is there. I've got 0, minus 2. 0 is there. I need to plot that in the wrong place. And then 0, 2 on the other side. And my 1 in the middle is minus 1, 0. It's there. You can see this is one of those parabolas again. Hopefully yours is a bit neater than that. Yeah, something like that. The posh version looks like that, so it's quite close, isn't it? Yeah. An example then, it says work out the values of t and x for the parametric equations. Alright, this is a different way of doing it, isn't it? You've got given the parametric equations and you're told that y is 18. Straight away I'm just thinking, well, I'll just chuck this into here. That gives me 18 divided by 3 is t squared, and t squared is 6. So you can see this gives me a value for t effectively. Square root it, t equals square root of 6. But notice it's left a gap because theoretically it could be either plus or minus. It doesn't say which one it is. And it does say values as well, so that might be a bit of a hint. Anyway, so now I've got my t, x equals 4 plus 2 root 6, or minus 2 root 6 actually. It could be either. Let's see what we're up to. Yeah, that's exactly how I've written it. Plus or minus root 6. And 4 plus or minus 2 root 6. So I like that, it was relatively easy. Find a possible parametric equation for these curves. So very similar, I suspect. It looks on the face of it. So I've got 3 of them. Now, it says x equals 5t plus 2. They give me one of them. Oh, this is like a backward one, I suppose. So on these, you get given one of the parametric equations. You get the Cartesian. You're asked, find the missing, because normally you'd have a y equals something or other. So that's what I'm after, I suppose. So it says x minus 10y equals 7. So rather than that, I'm going to write 5t plus 2, because that's what x is. Minus 10y equals 7. So presumably 5t, move that way, and move that way. I reckon minus 5 equals 10y. Divide by 10. Y is, well, it's a half of, well, I could write half of t minus a half. Or I could put a bracket there as well. So that's what I think the first one is. I don't know. B, I've got y is 4 sine theta. Well, it's so tempting, isn't it, just to think to yourself, I know what this is going to be because I've used that cos squared plus sine squared so often. I won't. I'll do it properly. 9x squared plus, well, sine, it says y, and that's 4 sine theta. That's 16 sine squared theta equals 16. Well, okay, move this over to the other side. That'll give me 9x squared equals 16 minus 16 sine squared theta. And I vaguely remember taking a common factor out on the example I had here, so I'm going to do the same here. 1 minus sine squared theta. Now that's important. That is really, because I know that cos squared theta plus sine squared theta equals 1. So you can see quite clearly that cos squared theta is 1 minus sine squared. It comes up loads, 1 minus sine squared. So this is 16 cos squared theta. To figure out this is 9x squared. Want to write x squared is 16 over 9 cos squared theta. And I desperately want now to get x. I can do that by, it's just square rooting. 4 over 3 cos theta. And technically it could be plus or minus, I assume, but it does say just give me one of them. I'm just going to get rid of some of my annotations, so I've got space to do the last one. Good. Now let's go back to the C. I don't even know what C said. C. 6x plus y equals 7. That's interesting. They've got both of them this time. Let's just go with it. Let's just go with it. It says 6x. So 6x would be 6 lots of p plus t, because it says that x is p plus t. And it says plus a y, well that's 1 plus qt equals 7. It's a bit weird, isn't it? So if I was to tidy this up, what am I after? I'm after, well, I suppose I'm after values of p and q which make this work. That's the only thing I can think of. Because I notice on this left hand side there's t's, but on this right hand side there aren't any t's. So I think what that really says to me is when I add these together, let's just do it, 6p plus 6t plus 1 plus qt equals 7. 6p. So the t's, I think they have got to have, on the right hand side I've got no t's, so I think I've got to have 6 plus a q. That many t's plus that many t's has got to equal 0. So I think q equals minus 6. And in terms of the numbers, I've got a number there, I've got 6p, and I've got a number there, plus 1, and that's got to equal 7. Alright, I think 6p equals 6, p has got to equal 1. So I wasn't quite sure what to do. Just sometimes you play with it and it works out. So that's what I think the answer is. Let's have a look. That was the one I'm most concerned by, that, and they've written that one as exactly the same way. So a bit of a summary for you now, I suppose. Finding parametric equations, usually we're going to get circles. You know, expect circles. Now last time I summarized this, I gave you the easy one. You can get the more complicated circles where it's not at the center. So it's x minus p all squared plus y minus q all squared equals r squared. These will have these parametric equations. Look out for them. X equals p plus r cos theta, y equals q plus r sine theta. I think I said alpha there, theta. So look out for these. If you see them, you think, they are circles. But it's not got a center at the origin. It's got a center at p, q. Then we've also got ellipses. So if you've got ellipses, the standard way of writing an ellipse is like this. So it's x minus p all squared over a squared plus y minus q all squared over b squared equals 1. Now, to be honest, we don't really see this much at A-level maths, but what we do see is the parametric equations. And the great thing is it's very similar to this, whereas this one's got r and r. No, it's a and b. It's just two different numbers. And if you get two different numbers, it's a stretched circle, and with stretched circles called an ellipse. So, broadly speaking, that's exercise 12B done. We'll obviously need to practice it. I think we did question 4 last time. So we're going to look at the other questions and just plow our way through those, and we'll try and get as many done as possible. Okay, thank you.